This video is going to talk about kinetic energy. Students will be able to identify the components of kinetic energy and how work and kinetic energy are related. Go ahead and get something out to write on and write with, and let's get started. Merriam-Webster defines kinetic as of or relating to the motion of material bodies and the forces and energy associated therewith. Or in other words, kinetic energy is energy due to an object that's moving, or an object's motion. It's a bit easier to understand. The equation for kinetic energy that's on the BCPS formula sheet is Ke equals 1/2 mv squared, where Ke stands for kinetic energy measured in joules, just like work. M stands for mass, measured in kilograms, and V stands for velocity, measured in meters per second. So only the V is squared, not everything else, just the velocity. Let's talk about some units some more. In case you didn't notice, kinetic energy and work have the same units, which are joules. It's not a coincidence. Doing work actually means that you're changing an object's energy, in this case kinetic energy. So some examples of things that can change an object's kinetic energy by doing work are a car's brakes, a car's engine, a car's airbag. These things all do work to change the speed and kinetic energy of an object. Work and kinetic energy are very much related. So doing work results in a change in kinetic energy. And that's what this equation is showing that the work done is the same or equal to the change in the kinetic energy. So if the brakes on the car do work to stop the car, then its kinetic energy would decrease by whatever amount of work that was. Let's try a challenge question. Say a car is traveling at some speed, v, with some amount of kinetic energy, Ke. If the car's velocity is doubled so that it is equal to twice v, what happens to the kinetic energy of the car? Is it the same, so it's just K? Is it half as much? Is it twice as much? Is it 4 times as much? If you're thinking 4 times as much, that's really good thinking, because the V is squared, and doubling something that's squared would be quadruple as much. Another one. A car of mass m is traveling at some speed v with some amount of kinetic energy Ke. If the car's mass is doubled so that it's equal to twice as much mass, what happens to the kinetic energy of the car? If you're thinking, man, the velocity made it, when the velocity was doubled, there was quadruple the kinetic energy, so why not quadruple again? Unfortunately, this would be wrong this time. Mass is not squared in the equation, it's just sitting there by itself. So twice the mass would mean twice the kinetic energy. Thanks for watching. As always, make sure you take the Edmodo quiz online to receive credit for the notes, and bring those notes with you to class next time so you can use them on the note quiz. Thanks for watching.